Myself, my name is Dave Sachs. I'm a distinguished technical marketing engineer with Cisco. I've been with Cisco about 19 years. Inside Cisco, we say we live in dog years. So if you're a little dog, that's 5 years per year. If you're a big dog, that's 7 years per year. So on that basis, I've moved with Cisco anywhere from 95 to 130 some odd years so far. Starting to get the gray hair to prove it. So basically what I work on inside Cisco is three primary things. I work on our next generation ASIC architectures in silicon. I work on our fabric architectures, which is everything that we're doing around software-defined access, and I work on assurance. Those are kind of my three primary focus areas within Cisco. I am joined today by my able and lovely assistant, Anand. Anand is going to be walking us through some demos later in the session as we walk through some demonstrations of different capabilities we have, specifically demonstrations around what we're doing with wireless sensors, putting discrete wireless sensors in the network, on APs as well as discrete sensors, and also talking about what we're doing with a new capability called intelligent capture that we've come out with. So this is an agenda that for my portion of our next, I've got about 40 minutes on our agenda that I'm going to go through. These are three primary things I'm going to focus on, which are going to be an overview of what assurance is all about. We're going to talk through some DNA assurance for wireless, as we're going to spend most of our time, specifically talking about three areas you can see here: client health, network health, device health, client insights with wireless sensor and intelligent capture. And we're also, maybe interestingly for Mobility Field Day, we're going to include a wired piece, because one of the things that, I think, and I would hope that a lot of you would agree on, or at least I'd like to get your feedback on, is that wired and wireless networking are really coming together in a lot of ways. Most customers look at the network as a delivery vehicle for information and applications to their end users, and we want to deliver the same holistic experience regardless of whether it's across wired or wireless. So we want to talk about some assurance capabilities as they pertain to the wired network as well. All right, so we're going to cover that towards the end. So let's dive right in. When we take a look at DNA assurance, why did we start going down this path of providing this capability that we call assurance in the network? Well, one of the things we saw as we looked out at the industry over the last couple of years is we saw that it's not a case of too few tools. In a lot of cases, customers have too many tools and too many discrete tools that provide all sorts of different data points, but no holistic way to tie all that information together across all the data. So in a lot of cases, customers are drowning in data, they're drowning in syslogs, they're drowning in NetFlow records, and they don't really have any way to make sense out of all that data that's coming in. Also, another thing that we saw is a lot of systems are very reactive, that are typically based on a user calling into a help desk, reporting a problem, and that's where the troubleshooting starts, whereas in a lot of cases, if you had a more proactive approach, you'd actually be able to spot a lot of those problems before they come about. And the third one is really limited insights. Again, that ties back to the fact that we've got a lot of data. We don't necessarily have a lot of conclusions that today's existing tools draw out of that data to let you actually take action on what you're seeing, right? So these are some of our primary motivations. And I'm sure everybody's seen what we're doing around what we call the network intuitive. I can sum up network intuitive and what we're doing there in two primary slides. Our goal here is to move towards what we call intent-based networking. This is a huge drive across Cisco and indeed across the industry as well. We're kind of leading the charge with this. Basically, the idea here is that instead of actually going in and having to configure all the discrete elements in the network and what you want all those individual pieces to do to tie together a holistic solution, like our customers have had to do for the last, let's say, 10, 15, 20 years, we want to give the ability to up-level that conversation where people can actually say, it's my intention to have, let's say, this application treated with a certain level of priority across the network. And then like Jean-Luc Picard on the deck of the Starship Enterprise, you push a button and you say, make it so, and we render that intent into action in the underlying network. So for example, you prioritize this application. This particular device over here has 2 priority queues. This has 1 priority queue. This has different queuing structures. Instead of a customer having to deal with all that, we make the tools deal with that and render your intention into the underlying actions necessary to establish that capability end-to-end across the network. And again, it shouldn't really matter whether that network is wireless, whether it's wired, whether it's both. We want to offer that intent-based paradigm. And so a lot of things you're going to see with the tools today, we take a look at DNA Center, for example, you're going to see that intent-based mechanism, that intent-based capability percolated throughout the tool, right? That's really what we're trying to drive. The other aspect of this is pulling back context from the underlying network so that we can pull back information, we can pull back NetFlow data, we can pull back syslog information, we can pull back streaming telemetry information, and be able to understand how the network is performing and how it's performing in real time, or as close to real time as necessary. So this is, again, we're not hurting for the amount of data that we can pull out of the network. The network is actually a huge lake of data that we can pull information from. The question is, what do we do with all that data, and how do we form that up into actionable insights that people can say, yes, this helps me understand how to go through and troubleshoot this particular problem, or how to optimize this component or this portion of the network, right? So it's really intent and context. Now, this is the way that I kind of picture what we're doing with digital network architecture. It consists of 4 layers in the cake, if you will. Bottom is infrastructure. We have automation, which is really about defining abstractions in the network and pushing policy. We have analytics, which is the primary area we're going to focus today. And then we have integration and orchestration on top. So the primary area where we're going to spend a lot of time, at least in my portion of the session today, is going to be around the analytics piece. How do we pull back data from the network? How do we analyze what's going on so that we can understand better how the wireless and wired network is performing? Now, our tool for doing that is DNA Center. So DNA Center effectively consists of 2 major functional pieces, or blocks, if you will. The first one is around automation, being able to easily define functions in a network. I want to have these different devices perform these different roles within a network, and then I want to automate that capability into the underlying network. So this is leveraging functions like plug and play, for example, for device onboarding. We're doing inventory of devices as we bring them into a system, assigning them to different roles, driving configurations down onto the devices. The second part of this is pulling data back into the assurance capability so that we can analyze that data. We can pull that information in from multiple different sources, analyze it, correlate it, and again, drive us towards actionable insights. All the information from the automation side is driven over to the assurance side in terms of capabilities like inventory, topology, and information that we have on the assurance side. An assurance set of capabilities is provided to us in terms of telemetry and alerts that we pull back. Now, ultimately, if we double click on that, you can see that, for example, we've got all our infrastructure devices on the bottom, reporting up all the information that we're looking for. What we then do is pull all that information out of the devices, collect it, and run it through actually a very comprehensive set of processing that happens inside DNA Center. The goal being that no matter what that data was or where we pulled it from, we want to form it up and present it to the user as a set of actionable insights, things that you can actually understand. How is the network performing? What am I seeing in the network? How is the network ultimately able to answer questions about how my application's performing, how are my users able to connect to the network, and where do I have any issues or challenges. Now, one of the things that we see is that traditionally the way that we pull this data out of network devices is through SNMP. It would be through CLI. It would be through all the traditional mechanisms as we use to talk to devices. One of the things that we're very focused on is moving towards a future where we're pulling this information out using streaming telemetry. Streaming telemetry is basically based on Yang data models. So we have a Yang model, kind of an idealized model of the device, and we're pulling it out through standard network protocols like netconf and restconf out of the device. Now, the advantage to doing this is you're pulling out data in one format. It's a very highly structured format, and you're able to pull that out in a way that is much less impactful to the performance of the device itself. We all know that, for example, that doing an SNMP walk on a device can be highly CPU intensive. Streaming telemetry can lower the CPU utilization and at the same time give us the ability to have the device be a bit more intelligent about how we pull the device, how we pull the information out. So being able to do that not just on a periodic basis, but also on a demand basis, for example, when something is exceeded or threshold is exceeded in a device. Now you can see here on the wireless side, the various different mechanisms we have for pulling information out of APs, out of wireless sensors, out of WLCs in the network. One of the things that we're going to focus on, for example, later when we talk about intelligent capture, is how we're able to pull actual partial or full packet captures out of an AP, and indeed across multiple APs as the user roams around, using gRPC, Google RPC, right, as a mechanism that we use to pull that back to the DNA Center. So let's delve in a little bit more on DNA Assurance for wireless. This is a quick overview of the various different capabilities we have, 100,000 foot level. Some of the things that I'd really draw your attention to here are information like intelligent capture. We're going to talk a lot about that, being able to pull PCAPs out of devices, and importantly, not just being able to pull a PCAP out of a device, but actually doing forensics on it so that we can actually have DNA Center analyze the packet stream that we're pulling from the device and tell us what the actual underlying problem was that we're seeing. Why is this user not able to onboard? Why did this user get deauthenticated off of the network? We can pull a lot of that out of the packet streams, but instead of you as a network engineer having to go through and analyze the packet streams to figure that out, we can apply a lot of intelligence inside DNA Center to define what the underlying problem was, right? So this is some of the things we go through with assurance. There's lots of different use cases that we cover in DNA Assurance. So this is an example of some of the things we do around client onboarding, network coverage and capacity, device monitoring, application performance, client experience. I won't go through all these in detail. We're going to show you these as we go through the demo. We're going to show you a number of these. But the important thing here is that we're trying to deliver a cohesive experience across wireless, across wired, that can really let you drill down as to what the underlying issues or challenges are that you're seeing as you're managing the network. And also being able to baseline the network so you can understand how the network is performing. What does normal look like in the environment? How do we know what abnormal looks like in the environment? That's different in every network. Now, one of the keys to this is, and one of the reasons Cisco is able to deliver on this is we actually design our hardware to be able to deliver on these type of capabilities. If you take a look at our latest access point, the AP4800, we actually have 3 radios in this access point. We have 2 client-serving radios, which are software programmable. They can be set to operate in a 2.4 gig band or the 5 gigahertz band. So for example, with the 2 software programmable radios, you can take one of them and operate it in 5 gigahertz, the other one in 2.4, or you can have both of them operate in 5 gigahertz with a macro microcell architecture, which is pretty popular. You could actually have a macro cell on one channel, which is a lower power, associating clients that are closer in, and or a microcell, I should say, and then a macro cell that is associating clients that are farther away, right? So software programmable radio gives us the ability to do that, but the third radio that we have in here is dedicated for analytics and location capability. So a third radio is really key because this lets me do, for example, packet sniffing at the same time I'm actually serving clients on a radio. I don't have to take a radio and make it do double duty to serve clients and do analytics. We have a dedicated third radio in there. Not only a third radio, we have dedicated antenna elements within the AP that are designed to deliver on this. So for example, I can have certain antennas that are serving traffic out to clients. I can have other antennas which are sniffing traffic that we're sending out to clients or receiving back. And that's actually really interesting to RF. So if you ever get a chance to go through a presentation like at Cisco Live about the RF characteristics of how we do this, it's actually really interesting because you're sniffing traffic at the same point you're transmitting it. You have some really significant power issues there that you have to deal with. It's a great presentation that's done at Cisco Live that talks through the details of how we do this. So suffice it to say that we design our hardware to be able to deliver on these type of capabilities. That's really important. There's capabilities that we're delivering and want to deliver with wireless assurance that you wouldn't be able to do on just a generic piece of AP hardware. That's one of the reasons we're very proud about the hardware that we built.
Hey, let me interrupt you there.
Yep, go ahead.
So, talking about the hardware aspect, the 8540s and the current controllers are pretty long in the tooth, so it kind of raises the curiosity a little bit when you talk about the hardware being designed for this. Those obviously came before DNA. How do you reconcile that?
Well, the nice thing about platforms like the 8540 and 5520 is that these are highly software-based platforms. So if you take a look at those platforms as controllers, fundamentally based on multi-core Intel CPUs, very flexible. We can adapt them to new functions.
Yeah, I guess I'm talking about the complete system, not the hardware, but
sure.
What they are and what they do predated DNA,
right.
And that's what I'm talking about.
Well, it's always about the right mix of doing the right things at the right place in the network. So some of the things you're going to do on the controller, if the controller is the right place to tap that information out. Other things, the right place to tap the information out is actually at the AP. So for example, when we take a look at intelligent capture later, the intelligent capture function is done at the AP. We're actually going in and taking the packets from the AP and streaming those back to DNA Center. They're not being streamed through the controller. So implementing a function like intelligent capture doesn't really place any additional burden on the controller itself.
Put a finer point on it. It feels a little weird from the customer perspective to put new magic on an old box. That's where I'm coming from.
Yeah, I guess
that's the way it feels.
I guess it just depends how much headroom or how much gas the old box has, right? So one of the things we did when we developed platforms like 8540 is we put a lot of headroom into the boxes in terms of CPU horsepower, in terms of memory, so we're confident the platform could deliver on everything that we're doing. It's also interesting how network architectures themselves change in a way that can actually constrain or remove some of those bottlenecks. So for example, when you take a look at software-defined access, we actually take the data plane. If you're implementing the 8540, for example, with an SDA deployment, a fabric deployment, the data plane would no longer go through the controller. The controller would be purely control plane functions, still running RRM and RF management and all the things that it does, and client onboarding, all the things that it traditionally does, but doesn't handle a data plane. The data plane is distributed and it runs in the network using VXLAN and CAP. right? So as we go to different types of architectures, sometimes we might add more burden onto a controller. Sometimes we actually remove burdens from the controller, right? And in my opinion, it's all about doing the right thing at the right place in the network. You don't just automatically assume that everything has to happen at the WLC. Sometimes the right answer is things happen down at the AP as well.
Yeah. No,
Right.
thank you.
Make sense? Cool.
So if someone were to have, 4800s in the controllers and not DNA Center, they lose out on that capability of like the auto PCAP. Is that correct?
Yes, the intelligent capture function is what's driven through DNAC. The functionality exists on the AP, but the way that we automate that and what we do with pulling the data back is a function of DNA Center.
Is there any plans to make it available outside of DNA Center?
Not really at this point in time. We've got a lot of capability that we want to deliver within DNAC with a function like intelligent capture. In my opinion, we're just scratching the surface with what we're doing with intelligent capture right now. I think we can expand that a lot more, and our platform for doing that will primarily be around DNAC. The protocols that we're using inside DNAC are all open protocols. There's no reason why those protocols couldn't be leveraged by something else, but we currently don't have any direction outside of DNAC
It
to
does bring
exploit
up
that
a
capability.
good question, though. I mean, is the future DNAC nothing? Or if you truly don't want to buy into DNAC, you can still be a Cisco wireless customer?
Oh, sure. Yeah.
Okay.
Yeah, you don't have to deploy DNAC. Our hope is that we put enough things inside DNA Center that are compelling for you that you're going to want to adopt it, right? But yeah, I mean, we're not mandating a DNA Center, but we hope that we get to a point where you'll just want it as a default because of the things we do. So yeah, go ahead.
What's the advantage that Cisco has with offering a physical appliance like this versus vendors that will do the same functionality but without physical appliances and are completely cloud driven?
Sure. So I mean, there's pluses and minuses to putting things in the cloud, right? On the plus side, cloud makes it easier to deploy, easier to scale, right? We've proven that with functions like Meraki that are entirely cloud-based, very easy to deploy, very easy to scale out a solution like that. On the minus side, some customers have a problem with things being deployed in the cloud and demand an on-prem solution. In my opinion, you need to have both, right? Ultimately, you need to have a cloud-based offering, you need to have an on-prem offering if you want to offer the entire coverage to the market, right? If you're only serving a portion of the market or a certain subset of customers, then maybe you can just offer a cloud-based solution and that's good enough. There's certain customer sets that in our experience just won't accept that or can't accept that for regulatory reasons. And so in my opinion, you need to offer both, right? Right now we're focused with DNA Center being an on-prem solution. We can speak later in the presentation about what our thoughts are about moving that into the cloud. Make sense? Mm-hmm. Cool. All right. So let's drill down a little bit into the kinds of things that we see here inside a network health and client health. Obviously, it's DNA Center, logging into DNAC. This is the initial splash screen that you would see when you log into DNA Center. So let me just point out a few things that you would see on here. You see up here an overall health summary. Get 87% healthy, for example, in devices, 100% healthy wireless clients. So what does that mean, that percentage? There's a whole bunch of KPIs, key performance indicators, that we crunch through on a device to come up to a health score, either kind of a 1 to 10 health score or a percentage health score, so you can get kind of an at-a-glance view of how is my network performing. That's what you initially see when you log into DNA Center. Now, of course, first thing you don't want to do is I see a number like 87%. I want to drill down into that and drill down into that and drill down into that to see what maybe the underlying problems are in that area. Why isn't it 100%? So one of the things you see as we take a look at this, for example, on that overall health screen, I can see in this portion, I'm taking a look at my wired network, I can see that I actually break out things like core and access and distribution and controllers and access points. So again, I can start to, as I drill down, I can start to get a good idea that, hey, my wired network looks like it's performing well, but it looks like I have a few challenges over on my APs, and that might be where I want to focus my attention. The other thing you see here is we always roll up a continuous rolling log of the top 10 global issues in the network. So I can see immediately what are my top issues, what things need my attention. I can scroll down that list and see this. We'll see all this later as we go through the live demo. I can again see my performance up here for wired clients, wireless clients, and from at least, when I've double clicked down to that next level, I can now start to see what some of my issues are in the environment. When I go down, for example, and take a look at this here, I can see my APs. And if I hover over that, I actually get a pop-out here that tells me what the problem is with those 5 APs. As soon as I hover over that bar, I see that I've got some high noise on some of my APs. I might want to, again, drill further into that to find out what the issue is in that particular area. So what we're doing here is we're summarizing up what we call device scores. So a device score is basically the lowest of all the different KPIs that we're measuring for the device. So I might have, let's say, on a device, half a dozen KPIs that I'm monitoring. 5 of them are top, so they're all good. And I've got one KPI that's lower. The health score for that device is going to be the lowest of all the KPIs that are associated with it. You get all these slides later, so you can take a look at this. It's just a little bit more detail about how we calculate health scores. Suffice it to say, what we're trying to do, remember that intent-based paradigm that we're going towards? We want you to be able to get a simple view of the health of the network, of the health of the environment, of the health of a device, with by summarizing all the information and presenting that in a more consumable format. That's what we're really trying to do with health scores. So for example, if I drill down into the wireless clients, I can see in this particular case, I've got 540 clients I've seen in this network, 501 of them are currently active within the environment. And I can see that I've got some problems. I've got this 88% health score in here. If I go over on this side, I can see what percentage of my devices over here are associated with problems. So I can see, for example, I've got some AAA failures. I've got some connectivity issues. That's actually the bulk of my problems here is associated with connectivity issues that, again, I can double click into and I can drill further into that. When I go into that second level drill down, for example, I go into a device, I can see here that, maybe I've got problems with, or I want to get a view on radio utilization on the devices. I want to see how utilized are the devices themselves, right? And I could go into that. I could take a look at the individual APs. I can see which code they're running. What is their overall health score? I can hover over that and get more information on it. And I can see in this case that I might have some challenges around how utilized the radios are, and that's why the health score has gone down. Yeah, so I'm going to just turn that down. Sorry. Apologies.
I just have a question.
So what? Yeah, go ahead.
Or feedback. Is this screen, from my standpoint, text really, really small, tough to read. Is it able to scale the size of fonts for old people who have bad eyes?
Sure. This is just a web browser. So I just captured these out of a web browser. Now, if you're up closer to it or you had this normally at distance that you would see all of these at a reasonable font size.
Seems like there's a lot of white space. There's just a lot of. Right. Our last one had a lot of dark space. This one has a lot of white space.
Right. Yeah, we do.
Less data.
It just has to do with user interface design and what you believe is the right kind of paradigm for. It's just in your browser. You can just zoom up and zoom down.
Is it tuned for mobile devices as well?
Yes. One of the things you have the ability to do is when you take a look at a device page, you'll see this on a couple of screens from now. We have a concept of creating dashboards with dashlets and widgets that you can put into them. Those are fully customizable. So if there's certain things that you really care about, like you don't care about seeing certain things, but other things you want to zoom up on, you can put those on your custom dashboard and say, these are the things that I care to see. These other things, maybe not so much.
Is one of those things the ability, I mean, it looks like there's more space between the letters than there are in the letters.
Right. So
is that a customizable piece, the leading in between?
The leading in between, not currently, no. The way that we show that is designed to make it very readable. If we compress things up, makes it very dense, typically makes it harder to read or maybe harder to find the stuff that you want. But that's good feedback. I mean, those are type of things we're always looking for in refining the user interface. One of the things you'll see as we go from DNAC version to version to version is we're always making improvements on the user interface. So maybe an improvement we should make is to make the display more adjustable. Some people like to get more dense information versus more spread out information.
Especially on the tables because, like you have the device names over on the left-hand side, and then there's this really wide gap. And when you start adding all those gaps in, sometimes you end up with
something that's really big.
Columns way over on the right-hand side, and you're scrolling back and forth.
Yep.
And a way to either shrink those down.
Sure.
Almost like an Excel. And manipulate.
Yeah, manipulate column width and stuff like that.
Column widths, and I mean, sometimes you're not really worried so much about the IP address because you're like, oh, I'm looking at
I don't
all
really
these
care
clients
about
are in the same subnet, so let's move the IP address column over to the far right because I don't need to see it.
Yeah, make that more customizable. Yeah, no, that's a good point. Those are all things that we should think about as we look to evolve the user interface. The other option, of course, you just go to your manager and say, I need one of those fancy 35-inch ultra-wide
Look, you've got
monitors.
an 80-inch screen here, and it's still not working.
Yeah.
It's not the screen real estate. It's the,
No, I hear you. I mean, customizability of user interface, I think, is a really good piece of feedback that we should take back and on board. So when we take a look at this is a bit of a live running demo that we've got running here. Here we see a particular overview of client health that we have in the environment. This is again an overview of all the wireless clients that I had in the lab at this point when I was doing this. And then what we're going to see is we're going to go search for a particular client in here. So we type in name of a particular client. What this is going to do is take us into the client 360 as opposed to the client overview. I'm now going to delve into 360 information as client. Maybe it's somebody called into the help desk with a problem. Now what we're seeing here that's interesting is a timeline associated with this. This was on August 24th. And you can see that timeline for the entire day. Now these little blips that you see here below, those are issues. Each one of those little red dots is where I had an issue in that timeline. And here I can see, for example, I'm going and hovering over a particular point in time when this user was having an issue. Once I hover over that, I'm seeing the actual data from that portion in the timeline. You got to remember, we have this all in what we call a time series database. So the time series database allows us to step back into time and take a look at not just what's happening now, but what's happened historically. So I can see all the information. This client at that point in time had minus 77 dBm, so their connectivity was not great. Their data rate was pretty low, and as we'll see as we take a look at this, they were dropping a lot of packets.
So how far back can you go? Is it just a day, and how long do you keep that?
No, we keep data for 15 days.
Okay.
So basically the last 2 weeks. You can step back to anything in the last 2 weeks in terms of data. So as we scroll down here, I can also see that I've summarized up all the issues associated with this particular client. So instead of just showing you the raw data and expecting you to know how to interpret that, we crunch through a lot of this data and bring that up to actionable issues and actionable insights. So here I can see I had some issues around network latency and packet drops. I had maybe a user that was in the wrong band. Now as I scroll down to this, I can also see, as we go down here, all the applications that user was running at that point in time when I clicked on that timeline. And I can see some pretty interesting things here. For example, one of the first things I'd look at as a network engineer are the DSCPs are marked wrong. So I've got some sort of QoS issue in the network. I expect to get AF21 or CS2 marked for these particular applications. And what I've got is 0. They're all marked at default.
Are you also running a client on the laptop itself?
No.
So you're pulling all of that application data.
This application data we're taking a look at here is pulled through what we call AVC on routers, application visibility and control, which is basically NBAR. Right, we pull this through NBAR. We also use a function on the router called application response time. So the ART would allow us to measure some of the metrics you see over here, like client network latency and server network latency. That's pulled from ART. This is what I mean about pulling data from multiple disparate sources. You're not just taking a look at data here, it's coming from WLC or coming from an AP. It's coming holistically from all the sources that we can pull, munging that together and showing you really how this user is using the network. A lot of stuff here I'm actually pulling from
client-based application.
Yes, this is all the applications of this, because I'm in client 360 right now. I'm taking a look at all the applications that this client was running at that point in time.
Is there stuff in here that shows anything about how long it's taken for DHCP or
Absolutely.
DNS and stuff like
Absolutely, you'll see all that.
Excellent.
Yes, you'll see all that as we go through it. So absolutely yes. So when you take a look at this, here for example, again, we're back at the client summary health page. You can see here some of the information as we zoom in on a specific to stuff around DNS or DHCP. Here's where I'm seeing the information that I'm pulling, for example, in this case on DNS. I can see how long a DNS response is taking, how long a request is taking, how long a response is taking in the environment. These are all things that we pull from the devices, but moreover, we can also do sensor tests. So these are like scheduled tests that would run within the network, so I don't necessarily have to wait for a user to call in with a problem and have to zoom into their client 360. I can take a look at the sensor tests, which are proactively running all the time.
What kind of sensors are these?
So the sensors, we have two different modes. I have slides later to talk about this, but I'll talk about now. We have a function, we can run a function called AP as a sensor. We can take devices like 2800, 3800, 4800, and actually run them as sensors. So they would run tests. Think of them like IPSLA tests. If you're familiar with that, it's very similar to IPSLA. We run scheduled tests, ping, HTTP, file transfers, mail access, these type of things, and measure all those components, DNS, DHCP transactions. We also have dedicated sensors. So we have a little thing called the 1800S, which is a dedicated sensor that would plug into the wall, just like a power jack that would plug into the wall. It's about the size of maybe 2 packs of cigarettes, and it is a dedicated sensor. Now the value of that is that that sensor runs at the desktop level where the user is. Where, for example, if you're running AP as a sensor, the AP as a sensor obviously is running in a ceiling. The users aren't there, right?
Closer to the user is better, obviously.
Right, closer to users better. That's a goal with 1800S. So we have both options. And we're actually going to demo that later. That's one of the things when Chandan brings this up, we'll actually show you the output from that. So drill down into client onboarding. We're able to see information about the client and how they onboarded. How fast is the AAA server responding, for example? How fast is the user getting authenticated into the network? Is the user getting authenticated into the network properly? We're able to pull up a lot of information about that client that helps us diagnose this person's called in with a problem to help desk. What is the underlying issue? What is the underlying problem? Right? That's really the goal here. So the way that we calculate these client health metrics, again, this is a bit of an eye chart, but you can see that what we're doing here is taking a lot of information like the RSSI, like the SNR, and rolling that up into a health score. So for example, if a client has very low SNR, they've got really good RSSI value, that's going to have a very high-end health score. Right? On the other hand, I can take a look at this and just at a glance, I can see that a client that's down in this area is probably not having a very good day on the network. So I can see the health score is
Are those adjustable on my end? As in, if I've got a barcode scanner, it's going to have a different, a 1 is totally acceptable, and a voice over IP handset needs a 5.
Yeah, fair enough. What we're trying to do here is we will show you all these values for RSSI and SNR so you can make that judgment yourself. But what we're trying to do is produce this in a more consumable format. The challenge that we see is people are flooded with data.
My fear is I would get a report back, I show it to the boss, and he goes, we got 2s everywhere. And it's like, yeah, 2s is actually our target.
Right.
I want to be able to say, for this subset, that's totally acceptable, but this guy needs a different one.
So you'd like
Because
to be
the
able to
connected health score would sound bad.
Maybe customize that like on a per device type of basis.
Per type, yeah.
Yeah, per device type.
Maybe
right?
even
So
for SSID,
yeah,
but some ability to not say, a 1 isn't always bad.
Yeah, it's very good feedback.
And especially if you color coded those to red, they're going to look at that and go, oh, no, we've got to change something. It's like,
right. Yeah, it's very good feedback. I think certain things like, for example, certain devices may operate quite well at a low RSSI value, or maybe more tolerant of impulse noise in the network because they're not sending much data, right?
or IoTs. I mean,
Sure. Yeah, being able to customize
IoTs
that,
would love 0.
in my opinion, good idea. In my opinion, good idea. We should do that. Yes. So this again is an example. Now, a couple of things I want to point out here. I mentioned this concept before of this time series graph database. So that's actually what we're putting everything into for all the assurance data that we pull back. Now, the value to that is, for example, when you take a look at this timeline, you can see this particular client. I can see every type of client. This particular person's used an iPad, a PC, and a phone up here. And I can see their entire timeline for their connectivity over the entire last week. Everything, this is 26th, 25th, 24th, 23rd. And I can see that all of their connectivity over that period of time. Now, you see these 2 blue bars up here? You can adjust those. So you can zoom in to a particular portion. You don't have to take a look at the whole timeline. When I adjust the blue bars to zoom in only on a portion of that timeline, I'm looking at only the issues or only the challenges that happened at that point in time. For example, the onboarding that you see there with the access point with the 4 below it, or the controller with the 5 below it, that's that instant in time that I said out of this whole timeline, I want to look at that portion of time. At that portion of time, and only at that portion of time, that's how many clients were on the IP then, that's how many users were on the wireless controller then. Right? So you have a lot of capability, because with this massive amount of data in a database, you can easily zoom in on a particular portion of time. Person reported a problem yesterday afternoon. I want to zoom in on that portion yesterday afternoon. I wanted to see at that point how many users were on that AP. Right? I could easily condition their performance. How many APs were on, or how many clients were on the controller in total at that particular instant time. And all the metrics that I look at for a user are going to be conditioned from that portion of time that I'm looking at only. That's the power of this time series database that we have inside DNAC, is that you're able to zoom in on just that portion of time. Right?
Well,
go ahead.
I was going to say, the historical information is excellent. You foresee a way of being able to act upon these kind of alerts when you see them, though, and
Yes.
have it remediate certain types of problems? Do you see that
Like
work?
automatic remediation.
Yeah.
So let me answer that question just 1 second, Amy.
Okay.
Because it's an involved answer, and I want to make sure I answer it properly. Other question.
mine kinda
and then I'll
bolts
come, and then I'll
onto
come right back to that.
Mine bolts onto that one, which
Okay, good.
is you do have this alert where there's a lot of clients on an AP.
Yeah.
Does this information feed into your RRM algorithm where you may utilize that macro cell and then go dual 5, for example?
Like to automatically switch over to a macro or microcell. So you could do that so that you could have, automatic deployment. I find that most people who want to deploy a macro or microcell architecture want to nail that in, right? Like you're going to want to say, in this portion area, in this portion of the building, I'm going to have 1 or 2 radios that serve on 2.4 gigahertz for clients that can still only use that, kind of an ever decreasing number of clients that can only use 2.4. I'm going to deploy the rest of my radios at, dual 5 gigahertz macro and microcell. So I typically find that most people want to hard code that because they want predictable performance. When you have radios that are flipping from 2.4 to 5, in my opinion, that's not good, right? Because it's quite client impacting when you do that, right? Client has to roam. So coming back to your question, Amy, your question was really around if I've got APs in the environment and, and I've got a wireless network built, and I'm seeing issues that I want to remediate, can I have the system do that automatically?
It doesn't have to be even just wireless. I mean, it could be if you see that the problem is switching or something, it looks like you've got the visibility into that as well.
Yep. So ultimately, this is where we want to get to, is automatic remediation of events in the network. In my opinion, it will take a while for you to trust us, for you to trust tools in the industry in general, in order to do that. In my opinion, it's kind of like having a self-driving car. If I have a self-driving car, I probably still keep my hands on the wheel, right? I don't need it to drive the car, but it makes me feel better. Might even be a requirement to keep my hands on the wheel. Ultimately, once the technology matures enough and you get enough experience, enough confidence with it, you're going to want to take your hands off the wheel and let the system drive itself. Technical capability exists today to do that. I think people have to gain more experience with the tools, and we're going to have to keep popping up dialog boxes for a while that say, this is a suggested remediation. Do you want to do that? Okay. Our hope is after clicking on OK for a while, 6 months or a year, you'll want to click the checkbox beneath that says always fix it this way. Then you get to a self-remediating system. But in my opinion, it's a matter of trust, right? These type of tools are quite new, and customers need to gain experience with them in order to move to a full remediating system. It's not a technical barrier, right? People really need to see that the remediation results that we're providing are the ones that you would have done anyway.
How far away are you from figuring out with that remediation classifying, oh, you might be hitting bug number X,
right,
or bug number, something like that?
Yeah, that's trickier to do, in my opinion, because you can have many different symptoms that can show up like a bug, even if they're not a bug, right? Especially around connectivity. I've got, things where I'm not able to get connected properly, I'm getting bumped up at a network. Ultimately, is that a bug? If we can correlate enough information from the underlying network, we're going to be able to present an ever-increasing confidence level that, it might be this particular issue, this particular DDTS. Not really our focus right now.
Or even maybe from a hardware perspective, just seeing like an access point reboot.
Yeah.
Or doing something like along those lines, not necessarily seeing a bug from a client's point of view.
Okay, right.
Yeah,
so
sorry, I should have clarified a little bit.
Yeah, so being able to see something like I've got an AP rebooted, pulling the logs from the AP after it reloads,
Exactly,
taking a look at it and going, okay, this log corresponds to that DDTS. It's not really a focus. There's no reason why we couldn't do that in a tool. In fact, long term, I think it's probably a good idea for us to be doing that kind of thing.
I think the trust factor would probably raise up quite a bit.
Yeah, it's
in my opinion, it's if we can actually kind of see some proactiveness. Okay, hey, you know what? We're seeing a lot of these.
Yeah.
Maybe we need to go and act on that.
Yeah, absolutely. Well, we would show you that today. We would show you those type of alerts. What we wouldn't do today is correlate that to say that these alerts look like it correspond to CSC DX, blah, 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 right?
Right.
But ultimately, there's no reason why you can't do that, and that's just another database that we have to correlate to.
To expound on that, as a longtime Cisco customer, there's such a history of bugs in the wireless, all the controllers and the code stuff. It's probably not a secret. I mean, there's just a lot of bugs.
Sure.
So when you talk about lofty concepts like AI and machine learning, again, from the customer perspective, running big networks, man, that would be huge. More so than, pointing at client trouble. You know, if you have a healthy network, it's probably not too hard to figure out. When you get a trouble ticket, that person probably needs to update their Windows driver. But the bug stuff is so huge and takes up so much time. Again, when you talk about the new magic, if you could funnel it towards some of the reliability and the true pain points for the network itself, not the individual clients, it would be time well spent.
Yeah, no, I think it's good feedback, right? Being able to pull that information out would be extremely useful, in my opinion.
So as someone not really familiar with the whole DNA environment and all from Cisco, how, with this being essentially on-prem, do you have the capability to push all of this data into a cloud to help you tune features and algorithms and, you know, how to determine what events correlate and stuff like that?
Sure. Like, how, you're just asking, how would we do that mechanically? Or
Well, can you? Because with this
Right.
on-prem, right, I mean, the whole thing is you want that to be constantly evolving, and potentially, is the way I would see it, would be to have it constantly evolve without the need for a code upgrade or outage of any kind, right? Even though obviously this is not, you know, anything that would involve client impacting performance at the time.
Yes. So one of the things that we've done inside DNA Center, architecturally internally, is built on a microservices architecture. So that means that you see it as one appliance that's sitting on-prem, but internally there's dozens of microservices that are running inside. So when you upgrade DNAC, you don't upgrade it monolithically, you upgrade it as packages. It will come down in a series of packages. You upgrade this package, this package, this package, this package, right? So upgrades are typically a lot less impactful. You know, one of the things we need to be cognizant of as we move to a cloud-based model is how much data we're streaming out to the cloud, and what is that data, right? How do we anonymize the data if it's moving out into a cloud environment? What are the regulations around, you know, any of the European regulations, data protection regulations come in recently? Make sure that we're corresponding to those.
So how are you getting, I guess, let me ask it a different way. How is Cisco getting data from actual customers using this to help the product and its intelligence grow outside of you just working in your labs and stuff?
Sure. So one of the things that customers can do inside DNAC is they can enable the telemetry from DNAC, come back to us so we can see more about how are people using the product, which features and functions are they using, you know, how are their networks using DNAC, and you know what sort of things do we need to focus on and improve. Okay. That's part of it. Another part is continuous interaction with customers. Like even some of the feedback that we're getting here is great feedback, in my opinion. Things that we need to do to improve usability, to improve functionality of the product, right? It's a continuous process. So it's one of the things that we're doing on DNA Center is we deliver this on an agile model where upgrades are continuous. It's not like iOS where you get, you know, upgrade every 4 months or 6 months. Typically on DNAC, our upgrade cycle is more in the order of 3 to 4 weeks. Right? So every 3 to 4 weeks, there's a new package that comes out with a whole new set of functionality.
So as you're talking about these upgrades, are you having to reboot the system every time you're doing these upgrades? Or these...
Typically not.
Okay,
no.
that's good to hear. Every 4 to 6
so
weeks would not be fun.
I will move on to discuss if you. There's actually one other thing I wanted to cover back here at the end of well, I won't cover it because we went past it, but I'll explain it. One of the things you'll see when you go through this later is we have a path trace capability inside DNAC. Now this path trace capability is really cool because what it lets us do is trace the entire path end to end for both the wired and the wireless portion of the network. So for example, when a user is complaining about a performance problem, that could be a problem in the wired underlay or it could be a problem in the wireless overlay. When we do that path trace, you see both the underlay component of the network, you see the overlay CAPOP tunnel that's riding over top of that, or if it's an SD access, you see the overlay VXLAN tunnel that's riding on top of that. So you're able to see the entire path that user's traffic has followed from A to B. You're not just dealing with, you know, the wireless overlay, but you have no visibility into the underlay, right? That's really critical in my opinion in terms of troubleshooting problems, because the problem could be at either layer in the network. It could be a wired problem, could be a wireless problem, and you need to be able to troubleshoot both. So other things that we can see in here is I'll move on to talk about sensors and how we employ sensors in the environment. As I mentioned before, we have 2 different types of sensor functionality you can do. We have dedicated sensors, which is 1800S, and we have AP that can be run as a sensor as well, right? So these are 2 different options that you have. When we're deploying APs as sensors, we have different ways of aggregating the data. Obviously, all the APs are associated with the WLC. They're going to pull back their sensor data over a CAPWAP, and then we have WSA, a wireless service assurance channel that runs over to DNAC. The 1800S, these devices come up as clients on the network. So they are a client that is directly seen by DNAC. They learn the DNAC IP address through option 43. and then they actually stream their data directly back to DNA Center. So some of the different tests that you can run, you can see summarized here. I know it's very hard to see, but you'll be able to see these later. Things like IPSLA tests, DNS tests, radius tests, a speed test that we can run continuously in a network, file transfer test. I don't want to steal Anand thunder because he's actually going to do a demo.
Quick question on that,
Yeah.
on the sensor. And I'm not super familiar with the product line.
Mm-hmm.
Do you need the DNAC to use the sensor? Or can you leverage the sensor within a traditional WLC model?
So you're going to get a lot more functionality out of a sensor if you implement it in with DNAC.
Okay.
Right. So typically we look for these to be deployed with DNAC. You're going to get full visibility on a dashboard for that, and that's what Anand is going to show as he walks through his demo. The other thing I want to talk about, and then we're going to flip over to the demo portion, is to talk about intelligent capture. So intelligent capture is a really cool new capability that we've introduced on EAPs. This gives you the ability to capture a single packet stream for a user to do diagnostics, to do analytics, even if the user is roaming around the environment. So for example, you go into DNAC, you take this area of the floor and you say, for this client, I want to enable intelligent capture. Because this user is reporting a problem, I want to be able to do diagnostics. Now today, in a traditional environment, you'd have to roll somebody out to the site with a wireless sensor. You'd have to have them do diagnostics. You'd have to put out a wireless sniffer out there. It's a very time-consuming and expensive to do that, right? Here, what we're doing with intelligent capture is we're able to have that client to say roam around from AP to AP to AP. We're pulling back packet streams for that user from each one of the APs up to DNAC. We synthesize that into a single packet stream, which is what you see in DNA Center. So you don't see 10 different captures from 10 different APs. You see one capture that was captured across multiple APs, brought together, and then we do analytics on the capture. You can dump the raw PCAP if you want, but more importantly, we do analytics on it. So for example, here you can see we're analyzing this particular packet stream. We've got packets, the downward facing arrows are packets moving from the AP to client. Upward facing arrows are packets moving from client to AP, and here I can see a particular issue, in this case involving DHCP that the user had. So why don't I actually flip over to Anand, and Anand is actually going to demo packet capture for us. I'll just mention that we can do this in two different ways. We can do a full packet capture, which we can do in an AP 4800, we're capturing all the packets on stream, or in a 2800 or 3800, we can also do a partial packet capture, primarily used for troubleshooting onboarding. Question?
So before you get to that, a couple screens ago you showed when you were showing the sensor, you had, it looked like a physical appliance. So it's on-prem, but it's, so it's on-prem, but it showed a physical appliance right here.
Yep.
Is it only a physical appliance?
Well, the sensors are these portions over here. Like a sensor is 1800S or the functionality running on the AP, WLC, and then the physical appliance is DNAC.
So the DNAC is a physical. There's no.
It is.
There's no virtual option.
Not yet. No.
And so if you have to, is there a concern about expanding that?
Well, we have, we publish all the scaling limits on DNAC. So for example, on a single DNAC appliance today, we support 4,000 APs. Right? So you can support, pretty good, decent, mid-sized deployment, maybe not the biggest deployments that are out there, on a single DNAC appliance. We do have plans to scale that in future.
And what about client? I mean, is it a problem with the number of clients or?
Yeah, current number of wireless clients we support is 20K on a single DNAC server. Well, again, we have plans to expand that in future.
But 20K is simultaneous or?
It's simultaneous.
Okay.
Yes.
I gotta imagine, larger enterprises are trying to leverage this thing a lot. Are you seeing a lot of them right now that are running into issues because of the 4,000 AP cap?
Not yet. No. Most people with DNAC, they're starting to employ it in their environment. We have customers that are looking to future and saying, hey, we need higher scale, which we're certainly going to deliver, but we're not currently seeing that as a bottleneck.
And can you just, if you had the need to, you could
deploy
multiple ones?
Oh, sure. Yeah.
Okay.
Deploy multiple DNACs. So the way that we've built DNAC itself is on what we call a scale-out architecture. It's a microservices architecture. It ultimately lets us scale it out to multiple physical appliances and have it all appear as one server. That's the ultimate goal as to how we want to deliver this.
But if you do need to expand it out to 2 to get beyond the current limits, does that potentially require network redesign so things fit within them, or?
Not really.
Okay.
No, you just have multiple DNAC appliances. You associate some devices with this, some devices with that.
That's a manual thing where you basically say, okay, I'm going to push these guys over here.
Yep.
And
Point these ones to DNAC, point these ones to DNAC.
Is that per controller or per AP?
That is currently doing that per controller.
Now, for DNA, do you have to run ICE along with that?
So DNAC, typically, you have to, I mean, anytime you're deploying wireless, you have to have some sort of AAA. You have to have some sort of ICE, right?
Does it have to be ICE or can it be other AAA?
Well, it depends on the deployment type that you're doing. If you're deploying, for example, software-defined access, then ICE is a requirement for that. Otherwise, you can deploy anybody's AAA in conjunction with it.
I wanted to demo a couple of things. One is on the proactive monitoring, the sensor piece, and the second one is on the intelligent capture. So maybe due to lack of time, probably I'll straight away get into the intelligent capture piece. They pretty much went through all the steps, what is involved, but here's a live system. The use case is here. The username Cisco, he seems to have a problem on and off connectivity issues, and he calls the tech support that he's having a flaky network connection issue. So I look into my starting point is the client 360 page. I look at the client 360 page and I do see a lot of dips here. So, I really want to probably, the way the intelligent capture goes about is I schedule the captures, packet captures, because this user is frequently complaining that, that he's having problem. So I go to the schedule packet captures and just give me a second, I should have opened the tab, but so I already have these captures running. This is on a per floor basis with the users. It could be multiple, like could be up to 16 users. And the moment I hit this, when this user walks into the floor, the packet capture is immediately triggered and sent over the DNA center. And let's say if the client is roaming from one access point or another access point, the moment he associates, the packet capture is triggered and again sent to the DNA center.
And that's done seamlessly. So if I have multiple APs that the user is roaming across, I'm going to get a continuous packet capture with no packet loss as they roam from AP to AP to AP to AP.
Now, you mentioned by floor, and I don't mean to derail you, and I know you're tight for time, but what about, if it roams to a floor above or below? It doesn't matter? I'm just trying to...
No, you just have intelligent capture enabled for that area of the network.
And is that being run by the AP groups, or you?
No, it's run by DNAC based
It's
on
all
that.
DNAC. Okay.
Yes. So I'm going to straight away jump into the intelligent capture page.
So tell me a little bit about what we're seeing on this, Anand.
Yeah,
The
sure.
different areas.
So the top portion, what you see here, the top band, all the small square boxes and rectangles, these are all the onboarding events. When I say onboarding events, it could be the client association or roaming or reauthentication, whatever could be the events. So the green indicates that something good, and then the red indicates probably something didn't go well. And then the blue bar below that indicates there's an active analysis session is happening.
So you were doing packet capture anywhere on the blue bar portion of this? Okay.
I've already started a packet capture for the demo sake.
And I saw you had some others, but it had already been captured previously in sync.
Yes.
Okay.
On the left side that you see the event viewer, these are the events, the onboarding event, that it's live. You see it's live, and these are the events that I fit from the WLC.
Yeah, so all that information on the left side is synthesized from the WLC's view of the world.
And you have this floor map here. This information is obtained from the CMX. And if I scroll down, I have all this RF stats. This is the data that I get from the AP. AP is sending all these stats. So now I have a problem. The client reported a problem. So I pretty much knew what the problem was, but I still wanted to further narrow down. So let's say I'm going to filter maybe one of those red ones.
Yeah.
To
So
see.
remember I talked before about that time series database? What Anand's going to do here is going to grab that blue bar and zoom in on just a portion of this time series that we looked at for this whole client. We're going to look at just a bit of that time.
I'm going to narrow down on events. I select the sessions.
Yeah.
And I can just look only at anomaly sessions. Just highlights only the anomalies. So let's say there is a particular red event that I'm curious about. So when I select this event,
You've zoomed in on that event now.
I'm zoomed in on an event, and when I look at this, all the packets that's related to this event, all the onboarding packets related to the event is automatically analyzed by the DNA center.
And even the CMX data is showing me where the user was at that instant in time that I've zoomed in on.
Yes. And here is the packet exchanges. If you look at the AP is trying to, the down arrow, the AP is trying to send the EP request, but the client is not responding for whatever reason. And immediately the AP gives up and it kicks the client out and sends a deauth message. So I can just hover over this and then get the packet types, what's happening, the RSSI, the interpacket gaps, and so on. And if I really want more information, all I got to do is download the packet capture. I mean, what is going to happen is I'm going to get a PCAP here. This is my PCAP
Who's
file.
the target end users who's going to be using this and being in this interface doing this work?
So this is typically what we call a reactive troubleshooting workflow. If you think about what we're doing with sensors, sensors are proactive troubleshooting. Basically with a sensor, what you're doing is saying, I'm going to run all these tests in the network, I'm going to be proactive, maybe spot problems before they happen. This is typically reactive troubleshooting. The users reported a problem. This may be coming to maybe a second level analyst at a help desk who really needs to go in and understands the RF network, really needs to go in and troubleshoot this problem. That's a typical target user for this, I would say.
What kind of training is available for that individual in order to? It's more than just knowing how to use the interface.
Sure.
They have to have a broader understanding.
Oh, sure.
Of how,
They need to have a knowledge base of wireless. They need to know, what these different values mean and what EPOL means and why AP would dissociate a client after 3 missed EPOL starts, right? Granted, they would need to have that wireless knowledge. What we're trying to do here is instead of just giving you the raw packet dump, which is traditionally all you get out of a wireless sniffer, we're trying to do all the analytics on that to say, okay, the problem is right here on these red packets, and when you hover over it, you can see, the user's got wrong password. And it's a password fail. So a lot of cases, you'd be able to do much faster root cause analysis of what the actual problem was than you'd dig out of just a traditional packet dump. Now, it's also
you're adding
far
some
easier.
intelligence to lead them to the answer.
Right, but it's also far easier to get this. You can imagine that you could be sitting here in San Jose, that thing that you're analyzing could be over in Milwaukee. Right? Now, normally you'd have to send somebody out with a wireless sniffer onto the plant floor in Milwaukee to get that, and even then they'd have a hard time doing it because let's say they're following a forklift around a plant in Milwaukee, around a warehouse, right? How do you get your wireless sniffer to roam at the same time the client roams? Because roaming is client controlled. Now, even when the client roams from AP to AP to AP to AP, we get a seamless packet capture across all of them, rolled up into DNAC and presented as a seamless example of how that user's
Are
operating.
you getting the client side or the AP side?
Folks.
So we do both. We can do a wireless capture. We could do it like an 802.11 capture, so you can see all the 802.11 messaging, 802.3 capture of what we're sending out in Ethernet, or both.